What we're looking at here is a Hitachi V422 40 megahertz dual trace scope. It's a very attractive scope. It's in very good condition. It works very well. I'm going to take you through it. But just to kind of give you a quick look and an introduction to it here. All right, we've turned on the light. I'm going to give you a little better look at this in the light. Good stand. Got the rubber feet intact. The cord coiler extensions are in the back. Has a large 6-inch tube, which is as large as just about any of the oscilloscopes that I've seen, and yet it has it in a smaller cabinet. Fits quite well on just about any bench. This is a 40 megahertz scope. It does have a times 10 magnifier in it, which extends the usability up to about 50 megahertz. But it has AC or DC coupled inputs. You can choose channel 1, channel 2. You can alternate them, chop them, or add them. Vertical positions for both. The volt per division runs from 5 millivolts to 5 volts per division, and it does that in 10 steps. It has a continuous vernier for adjusting that calibration. The input impedance on the unit is about 1 megohm. It'll handle up to 300 volts DC plus any peak AC. The time base on the unit runs from 0.2 microseconds per division up to 0.2 seconds per division. It does that in 19 steps, so you get 19 ranges. Plus you have an XY position, so has a nice triggering system on it. Works well. As you can see, I'm going to dim the lights again. Make sure that you can see this easily. Alright, as I change the level of the trigger, you'll see we go in and out of lock with no problem. We can choose auto mode, normal mode. We have a TV vertical or a TV horizontal mode for vertical and horizontal frequency lock. If you're working on televisions. We have a magnifier times 10. We have, right now, superimposed both channels on top of one another. And just so that you can see that we are in calibration and tracking well. Alright, let's separate them. There. We have plenty of intensity in the tube. We can take it from nothing, visible, excessively bright. No problem. We have good focus. Take her from a blur, sharp, and blur again the opposite direction. So we've got plenty of high voltage. Everything's working nicely. The tube is still bright. We have an illuminated gradicle. See the gradicle shining up there. Should you need that. One of the nice features on this unit too is that if you wish to balance the channels, which let me demonstrate that channel balance here. Alright, I am in my most sensitive position on channel A, and I'm changing from my most sensitive to the next step up. That's from 5 millivolts per division to 10 millivolts per division. And what you'll see is that there is no change in the position on the screen. That's DC balance. In order to do that, you have to adjust the DC balance on the unit, which is often you have to approach the unit from underneath. You maybe have to take the belly pan off, or there's some holes that you go through. This one is very conveniently right on the front panel. There's DC balance for channel A and B right here. Basically insert a little screwdriver and you adjust that so that you remove any of the hop out of there as you're flipping back and forth. It's a nice feature. We have a another calibration called the DC offset voltage output. It's explained in the book. It's part of the calibration procedure. It's available from the front. And then we have a half volt 1 kilohertz calibration point to adjust your probes or take a look at the input signal, whatever. I'm going to go ahead and remove my common connection, and we're going to take a look at the channels independently and prove to you that not only are they calibrated and reading voltages well on all the ranges, but we also have our high frequency response intact. So bear with. Alright, we're connected to our voltage source, and then we're feeding through a probe as a divide by 10 divider, and we are feeding in 20 millivolts. That'd be 200 millivolts on the generator, but then we divide it by 10, so we get 20. We got 20 millivolts AC coming in at a kilohertz here, and on the lowest scale, which is 5 millivolts per division, so we're 5, 10, 15, 20 millivolts peak, and that is what we wanted, and we see that we are spanned exactly plus and minus 4 divisions up and down. Now let's go to 50 millivolts, but if I remove my times 10 setting, and now we have 200 millivolts coming in, 50, 100, 150, 200, so we're going up and down 4 divisions just like we wanted. Now let's go to 5. This would be 0.5 volts per division. And again, we are 0.4 up, 0.4 down, which is what we'd expect. Okay, so let's put ourselves back on divide by 10. We're going to take ourselves back down to 0. Excuse me, the most sensitive, and we're going to come up 1 range. We are now at 10 millivolts per division, and we're going to change our voltage to 40 millivolts so that we span 4 divisions here. So give me a moment. Okay, we now have 400 millivolts coming in from the calibrator. We are dividing it by 10 at our probe, and we are showing on the 10 millivolts per division scale, we got 10, 20, 30, 40 millivolts up and down. So 40 millivolts, which is what you'd expect. It's 1/10 of 400 millivolts, and that's what we had coming in. So let's go ahead and take ourselves up. We are now at 100 millivolts per division. I'm going to remove my divide by 10, and once again we are 4 up and 4 down, exactly where we should be. Well, let's go ahead and raise ourselves up to 1 volt per division, and we see ourselves at 0.4 up and 0.4 down. So everything is scaling properly. This is on channel A. Let's take ourselves back, put our divider back on, and we're going to take ourselves to 20 millivolts per division. We are now feeding in 800 millivolts from from the standard. We are dividing it by 10. We are getting, on the 20 millivolt per division scale, we're up 4 and down 4. So it's 4 times 20 is 80 millivolts. 80 millivolts is 1/10 of 800 millivolts is what we're feeding in. So again, we're scaling perfectly. Let's go ahead and raise ourselves up from 20 to 200 millivolts per division, and we'll take off our divide by 10. Once again, we're spanning up and down point plus 4 divisions up and down. Let's take ourselves up to 2 volts per division, and we see ourselves coming up 0.4 in each direction, which is exactly what we would expect. All right, let's in order to get the last couple of ranges, let's start at 0.5 volts per division, and give me a moment, we'll set. Okay, now we're on the 0.5 volt per division scale, and we have 20 volts coming in off of our calibrator. We're dividing it by 10, so we get 2 volts. And if I count my number of divisions, it's 1, 2, 3, 4. 4 times 0.5 is 2, so that's 2 volts. So I'm getting the response for 2 volts, and it all figures with my divider. Let's go ahead and raise ourselves to 5 volts per division and take off our divider, and once again we're at full scale, and in this case we're at 5 volts per division, so it's 5, 10, 15, 20 volts up, 20 volts down. Working just fine. Take ourselves back down again. This time we're going to go to the 1 volt scale, and at 1 volt we need to change our calibrator once again. Okay, we are now feeding in 4 volts to the scope. We are going up 1 volt per division, so it's 4 volts up, 4 volts down. And in order to do that, I'm divided by 10, so I have 40 volts coming in. And we went to the 2 volt per division scale, and we've now gone up 2 divisions and down 2 divisions. And if I go to the 5 volt per division, then I'm up 1 and down 1 roughly. We have 0.4 up and down. So everything is as it should be. Let's pick ourselves up on B channel and give it a quick check. Okay. B channel, 1 volt coming in. We have 4 volts up, 4 volts down. That's as to be expected. If I go to 2 volts per division, then I'm half of that. I'm up 2 and down 2, and 5 volts per division. We're fractional, up 0.4 and down 0.4, I think. Okay, let's take ourselves down. We're looking at the channel 2 trace right now, 1000 hertz coming in, AC. We have 20 volts coming in. We're dividing it by 10 through our probe, and that means we then have 1, 2, 3, 4 divisions times 0.5 volts per division, and that would give us 2 volts. And 20 volts divided by 10 is 2 volts, so we're checking well. So that's working. Let's raise ourselves up to the 1 volt per division. We see ourselves fall to half scale. 2 volts per division. And then finally the last 5 volts per division. I'm going to go and take us down to the lowest here in a second, and we'll take a look at. Alright, we're on channel 2. We're on the lowest scale. This is 5 millivolts per division. We see ourselves rising 5 divisions, so we're at 20 millivolts. Let's go ahead and put ourselves on 50 millivolts per division and take off our divide by 10, and we see ourselves go full scale again, which is as it should be. So we are reading, in this case, 50 millivolts per division, 200 millivolts. Okay, and then let's go up to 0.5 per division, and we see ourselves fall to the plus or minus 0.4, which would be 1/10 of the 4 divisions up and down we had before, so that would be correct. Now let's go ahead and take ourselves back down, put ourselves on divide by 10. We're down to the 10 millivolt per division range. I'm going to adjust myself for 100 millivolts coming in. Alright, we have actually 400 millivolts coming in from the generator. We're dividing by 10, that gives us 40 millivolts. We are on the 10 millivolt per division scale, and we see ourselves going up a full 4 divisions, so it's 40 millivolts. 40 millivolts times 10 is 400 millivolts. We're right back to the generator voltage, so that worked well. Let's go ahead and take ourselves to the 100 millivolt per division scale and take off our divide by 10 now. And once again we see ourselves plus or minus full scale, and that's as it should be. And then finally let's hit the last range we're going to check, put ourselves back on divide by 10. We are on the 20 millivolt per division range. I want 800 millivolts from my generator, so let's take care of that. We are on the 20 millivolt per division scale. We see ourselves up 4 divisions, that's 80 millivolts. That means we since we're dividing by 10 through our probe, that means we have 800 millivolts coming in, and that's what our generator is providing. Let's go ahead and raise ourselves, our range now, to 2.2 volts, or 200 millivolts per division. Alright, we saw ourselves now get cut by a factor of 10. I'm going to raise myself up by removing the times 10 on the probe. Once again, we're going up full scale, plus or minus 4, so we're reading 200.2 millivolts. That's 800 millivolts up and down. 4 divisions times 0.2 is 0.8. So 200 millivolts per division, 800 millivolts up. So that's it. B channel is working great too. We're going to go ahead now and give it a frequency test, and just to make sure that we are within our frequency range of 40 megahertz. And bear with me, we'll do that.